I am doing well. Ready for a short week of school this week. We only have 3 days of school, Monday, Tuesday, Wednesday. We're off Thursday and Friday. Woo woo. Gotta like that. All right. Let's get going this week. So am I, except teachers, all of your teachers have meetings on Thursdays. Boo hoo. Not a big fan of meetings, but I guess have to do it to get Friday off. All right. Um, Last week, and much much awaited long weekend, we're definitely looking forward to. Last week we were talking about the product rule and the quotient rule, and then this week we're going to be talking about the chain rule. So let's do a little bit of review of the product rule. The product rule says if you have two functions that are multiplied together, that you have to use the product rule in order to come up with the derivative of those. So I always use this method where I just say, oops, I go u is equal to e to the x, u prime, and the derivative of e to the x is e to the x. And then v would be my second function, so that's cosine of x, and the derivative of cosine of x is negative sine of x. So then it's just inside. So my answer, my derivative, would be e to the x cosine of x plus outside, which is going to be negative sine of x e to the x. Now I can stop there. Some students, they factor out an e to the x, so they'd put e to the x and then they'd have cosine of x minus sine of x, which is perfectly fine. I didn't, mind either way if you factored and simplified it down. Most of the times I just leave it like this. I don't take it that extra step. And then the second one, I have the square root of x times the sine of x. Well, this problem, I would write the square root of x as x to the 1/2, because then when I take the derivative, that's just 1/2 x to the negative 1/2, which becomes 1 over 2 square root of x. And then v is equal to the sine of x, and v prime is equal to cosine of x. So if I multiply middle, that's going to be, I could write it this way. I could go sine of x over 2 square root of x plus outside. So that's going to be, I could go square root of x cosine of x. And that is the product rule. I was surprised at how well everybody did on the product rule. Any questions on that before we move on? Okay. Then we also, last week, we also had the quotient rule. Now the quotient rule, I'm just going to do this one. The quotient rule we set up basically the same way. We just say that u, and this time we use the top function, is the sine of x. U prime cosine of x. V is equal to e to the x, and v prime is equal to the derivative of that, which is still just e to the x. So inside, so e to the x cosine of x minus outside, so e to the x sine of x, all over bottom square. Well, this is e to the x, so I could write it like this, e to the 2x if I wanted to, or I could just go e to the x squared, which is perfectly fine. Either way would work. Now this one you probably could factor out an e to the x and then cross one off on top and bottom, but it doesn't matter if you do or not. It makes no difference. So that is the quotient rule. Now this week we're going to be talking about the chain rule, which is, oh, I guess we better do this problem. Every time you have different derivatives, you always want to make sure you keep on finding the tangent lines. In this problem, it just asks you to find an equation of a tangent line. Again, in order to find an equation, we need point and slope. So the point they gave me, which is awfully nice of them, but then the slope, I need to find the slope. So I need to find the derivative, because that's how we find slope. Well, the derivative of this problem, Again, I'm just going to go u is equal to x minus 1, u prime is equal to 1, v is equal to e dx, v prime is equal to e dx. Inside, so that's going to be e dx, plus outside, so that's going to be e dx times x minus 1. And now I can plug in my x value. So e to the first, so that's just going to be e, plus e to the first, which is going to be e, and then 1 minus 1, well, that's going to be 0. So this term is just going to cross off. So I'm left with just e for my slope. And now I can write my equation. I can go y minus 0 is equal to e x minus 1, or y is equal to e x minus 1 for my tangent line. All right. Quick review of last week. Get it out of the way. Now we're going to get into the chain rule, which is a little bit tougher. All right, the chain rule. Here is the mathematical definition of the chain rule. If f is a differentiable at the point u equals g of x, and g is differentiable at x, then the composition function f of g of x equals f of g of x is differentiable at x, and f of g prime of x is equal to f prime g of x times g prime of x. What are they talking about? All right, here's what they're talking about. The chain rule says, okay, now we've just worked on problems that we could use the power rule, product rule, and quotient rule on. Now let's say they gave me something like this. They said, okay, I have 2x squared, that's not 2x squared, 2x squared plus 3, all raised to the 4th power. Now, a lot of students, what they do is they just bring the 4 down, leave the middle alone, and that would be absolutely incorrect. Because this is really considered 2 different functions. We really have one function, which is really x to the 4th, and then we have this other function inside that is 2x squared plus 3. Now, what the chain rule says right here is that we always take the derivative of the outside, leave the inside, times the derivative of the inside. Well, what does that mean? Well, if this is just an x inside here, I would just bring the 4 down. So that would be 4x to the 3rd. But it's not just an x inside. That's why we call it, it's another function. So I bring the 4 down. I leave the middle alone, to the 3rd power, times, and then I have to take the derivative of the middle. Well, the derivative of the middle here is just 4x. Now, if I wanted to rewrite this, I probably would simplify it down. I would multiply the 4 into 4x, so that would give me 16x times 2x squared plus 3 to the 3rd power. So the chain rule says that you have to take the derivative, if it's anything other than x. That's why when we were working on all these problems, like if I gave you the sine of x, we would say that the answer is cosine of x. Well, what if that's not just an x? Let's say I gave you that as the sine of e to the x. Well, now what the chain rule says is if it's anything other than x, we have to take the derivative of the outside function. So this time the outside function is sine. So that would be cosine, leave the middle alone, times the derivative of the middle. Well, the derivative of e dx is just e dx. So this would be my derivative using the chain rule. Now we're going to be talking about trigonometric functions in just a bit. Right now we're just going to be talking about polynomial functions. So when you're dealing with a polynomial function, I always say it's outside inside rule. You take the derivative of the outside, you leave the inside alone, and then you take the derivative of the inside. So if I gave you something like this, 3x plus 1 squared, okay, so I bring the 2 down. Oops, I gotta turn on my marker. So I bring 2 down, leave the inside alone, and that would be to the 1st power, times the derivative of the inside. Well, the derivative of 3x plus 1 is just 3. So I would rewrite my answer as 6, 3x plus 1. And that's it. So if I gave you something like, let's say I said it was 3x plus 1 to the 10th power. Okay, well, I'm going to bring the 10 down, leave the middle alone, to 9th degree times the derivative of the middle, which is just 3. So my answer would be 30, 3x plus 1 to the 9th power. That is the chain rule. And so many kids, they want to just, they just take the derivative and leave the middle alone, and they don't take the derivative of it, which is totally incorrect. It does not work that way. All right. So now if I had something like this, first thing I do is anytime I have a radical, I know I can't take derivatives of radicals, so I just rewrite it. I would rewrite this problem as 13x squared minus 5x plus 8, all raised to the 1/2 power. So now I bring the 1/2 down, leave the middle alone, raised to negative 1/2, times the derivative of the middle. Well, the derivative of the middle is 26x minus 5. So if I was going to rewrite this problem, simplified, because I don't like negative exponents, I would go 26x minus 5 over to the square root of 13x squared minus 5x plus 8. All right. Before I let you work on one of them, any questions? All right. So let's see. All right. Why don't you do the first problem, and then we'll talk about the second problem. Six times 2x minus 7 to the 2nd power. Okay, so if I was going to do this problem, I'd bring the 3 down. Oops, got to turn on my marker. Leave the middle alone, 2x minus 7 to the 2nd power times the derivative of the middle, which is 2. So yes, I agree. That is the correct answer. Now, when I have a problem like this, in the beginning, a lot of kids would look at this and say, oh, I'm going to use the quotient rule. I wouldn't use the quotient rule on this. I'm going to rewrite it like this, negative 3, because there's a negative in front, so I'm just going to put on a 3, times t minus 2 to the negative 4th power. Okay, I'm just going to bring that t minus 2 up to the top, because now I can use the chain rule. I can bring the 4 down, so that gives me 12 t minus 2 to the negative. Oh! My dog just scared me big time. 1 second here. Sorry about that. That dog goes crazy sometimes. All right, so then, if I was going to simplify this now, I'd bring that back down to the bottom. I would just rewrite this as 12 over t minus 2 to the 5th power. Okay, does that make sense? Now you could use the quotient rule on it, but I would highly recommend not to do that because it's a little bit tougher. All right, now when we use the chain rule with trig functions, it gets a little bit more complicated. Okay, so sine of x, we know that the derivative of sine of x is cosine of x. Now what happens if it's not just an x in there? Then I have to use the chain rule. So this is the middle term, this is the outer term, so I'm going to take the derivative of sine, which gives me cosine. I leave the middle alone. But then I have to take the derivative of the middle. Well, the derivative of 3x is just 3. So I'm going to put that 3 in front. So my derivative would be 3 cosine of 3x. Now, if I have this one, a very similar type problem, I take the derivative of sine, which gives me cosine, leave the middle alone, times the derivative of the middle. Well, that's 6x. Now, when you have a square here like this is when the chain rule becomes interesting, because it's going to be a chain rule inside of a chain rule. I always tell kids, if you ever get a problem like this when you have the, sine squared or to the third or something, I would write it like this, because this is really what it means. Okay? So now, what does this mean? It means I'm going to bring the 2 down. I'm going to leave the middle alone. And that's to the first power. Then I'm going to take the derivative of this. But remember, the derivative of this, you have to use the chain rule also. So this is going to be cosine of 4x times 4. I can't see that 4 on the outside there. But do you see why it's a chain rule inside of a chain rule? Because you have to use it more than one time there for the answer. Okay, because those, anytime you have trig ones, oh man, does it mess up kids. All right, so let's try a couple of these. All right, so what would you get there using the chain rule to find the derivative there? What is the derivative of cosine of 3x to the fourth minus 2? Negative sine 3x to the fourth. I'm going to take the dollar sign as a 4, since that's where it is. 3x times 12x to third. Very good. It's exactly right. Nice job. All right. How about this one? This is an example where you have to use the chain rule repeatedly. Okay, so first thing I would do in this problem like this is I would, oh man, I'm going to change it a little bit in just a second, make it even harder. So the first thing I would do in this problem is I would rewrite this as the sine x squared to the 1/3 power. Okay, so then I bring the 1/3 down. So I've got 1/3 sine x squared to the negative 2/3. And then I have to take the derivative of the middle. Well, the derivative of this is going to be cosine x squared times 2x. So really, you had to use the chain rule 3 times on that problem. Kind of crazy. So you're using the chain rule inside the chain rule inside of the chain rule. So it's really using the chain rule 3 times for a problem like that. All right, let's try a couple more. I guess not. Okay, now there are, remember we had the derivative, we were talking about the derivative of natural log of x is just 1/x, correct? Okay, remember that rule? Now, what happens if it's not just x? What happens if this is not just x? What happens if it's the natural log of 3x squared? Okay, then it's really pretty simple. All I tell kids to do is just do u prime over u. This is really your u value here, right? So it does work on this problem. If this is x, and we said that the derivative of that is u prime over, I'm sorry, just u prime over u, well, the derivative of x is just 1, and then we just put it over x. That's my answer. So if I wanted to take the derivative of this, I take the derivative, so that's what, 6x over 3x squared. Now these usually will reduce down because you're putting a derivative over the same. So I would rewrite this as, what is that, 2 over x? Is that right? My simplifying is correct. Okay. So what happens if I have natural log of x squared plus 1? Well, that's just going to be 2x over x squared plus 1. Now we get into the hard ones, here and here. I don't think this one is as hard. I don't think D is as hard as C is. Okay, and why is C hard? Well, I'm looking at the problem and it's like, it looks like I'm going to have to use the product rule on this thing, because I have x, a natural log of x. So to me, that screams product rule. So I'm going to go u prime, v prime. So u is equal to x, u prime is equal to just 1. V is equal to natural log of x, and then this is just 1 over x, right? So inside, natural log of x, plus outside. Well, that's x times 1 over x. That's just 1, isn't it? So you have to always remember, I mean, you've got the product rule, quotient rule, you've got the chain rule, you've got the power rule. So those are all different rules that we have to follow. All right, I'm going to let you do letter D and see what you come up with that for that one. Okay, letter D. Three natural log squared times 1 over x divided by natural log of. I don't think that's right. Okay. And the reason why I don't think that's right is because when you look at a problem like this, this is my u value right here, x. This is just a whole nother function. I mean, if I had, so I'm going to rewrite this as natural log of x to the third power. So I'm going to bring down to 3. I'm going to leave the middle alone to the second power. Now I'm going to take the derivative of this. Well, the derivative of natural log of x is just 1 over x, isn't it? And I should be done there. So my answer, if I was going to write it out, I would just rewrite, I would write it out as, and then to the second power over x for my answer. Okay, does that make sense? Okay. All right. Then we also have, these are other derivatives, and you will not see these in too many places, okay? But they are derivatives that you should be familiar with just in case. If you have a to the x, okay, so if I had 5, let's say you had 2 to the x, then the derivative of that is natural log of a times a to the x. It's kind of a weird one. I've never seen it on an AP test, but it is one of the ones that you're supposed to know. So if I gave you something like 10 to the x and I asked you to find the derivative of that, you just follow this formula here. So this is my a value because it's a to the x. So 10 is my a value, x is my x value, so this would just be natural log of 10 times a to the x, which is just 10 to the x, done. If you have a to the u, okay, now that means it's something other than x. So if I had 10 to the sine of x, okay, that's my u value. then it's the same thing. It's just going to be the natural log of 10 and then times a to the u sine of x times the derivative of this, which would be cosine of x. Okay, so you just have to follow the formulas that they give you. And then if you had log a of x, so let's say I had log base 10 of x, the derivative of that is just 1 over natural log of a, which is 10, times x. Now, if it's anything but an x, if it's like, if I gave you the same problem, let's say log base 10 of a sine of x, okay? Do the same thing. It's 1 over natural log of 10 times u, then du dx. So my u value was, that's going to be cosine of x. Oh, I had to put sine of x in there first. Sorry, over cosine of x. And that's, but as I said, you will not see these. It's just something, you know, that AP says that you should be shown, but that's one of those that you would never get one on one of my tests. It's not going to be there, but they are there. You can take the derivatives of those. Okay, so here is a summary of all of the differential rules that we've learned. The constant rule, the power rule, sum and difference. We've learned the product rule, the quotient rule, the chain rule. We've learned all of the trig trig functions, the derivative of those, natural log, and then e to the x. Those are ones that you should have memorized. Okay. The chain rule is the one that's going to come in most often, guaranteed. All right. This is a problem. This is two problems off of the assessment this week. Okay. It says find an equation of the tangent line to the curve at the given point. Okay. I'd like you to do problem or letter A. I'm going to give you, it's going to take a little bit of time. I'm going to give you like 5 minutes to work on that and see what you get there. Okay. Okay, now that I'm looking at letter A, do we talk about e to the x or e to the 3x? I think we did, which is going to make it really tough to do that problem. All right, I better go back and check my notes out. I don't think we did. All right, what is the derivative of e to the x? That is e to the x. What is the derivative of e to the 3x? Well, when you take a derivative of something that's not just x, then it's going to be the same thing times the derivative of whatever's in the exponent. So that's going to be 3. So the derivative of e to the 3x is 3e to the 3x. What is the derivative of e to the sine of x? And that one, it's going to be the exact same thing times, not just e to the x though, because it's going to be the exact same function. So it's going to be e to the sine of x times the derivative of the exponent. So that's going to be cosine of x. Yes. So that's how you take the derivative. Okay, so let's take a look at this problem. If I wanted to find the tangent line here, the first thing I do is I write down point and slope, right? Because that's all I need to know in order to write an equation of a tangent line. So point, I'm going to put 2 in here. So 2 squared times e to the 6th, right? So that my point is going to be a really weird point. It's going to be 2 and then 4 e to the 6th. I'm not going to change this to a decimal. No way, no how. I'm just going to leave it like that because it's going to be some crazy number, right? So just leave it. Just leave it as 4e to the 6th. Okay? So that's my point. I've got a point. So now I need the slope. Well, in order to find the slope, I have to take the derivative. So u is equal to x squared. U prime is equal to 2x. V is equal to e to the 3x. V prime is equal to e to the 3x times 3. Inside, so I've got 2x e to the 3x plus outside, well, that's going to be x squared 3e to the 3x. Now that's the formula that's going to give me my slope. Ay. So I'm going to plug 2 in here. So I'm going to put 2, so that's going to be 4e to the 6th plus, I'm going to put 2 in here, that's going to be 4 times 3, so that's 12e to the 6th. So that gives me 16e to the 6th. That's my slope. I am not going to change that number to a decimal. No way. I'm just going to leave it as 16e to the 6th power. Okay, so now if I want to write my equation, y minus 4e to the 6th is equal to my slope, 16e to the 6th, x minus 2. Looks like kind of a crazy answer, right? Could you change those to decimals? You absolutely could. Would I? No, I would not. I would just leave it just like that because, you're not going to want to, be messing around with those decimal points. So just leave it as is. Okay, does that make sense? All right, so I'm going to let you work on the second one, part B, see what you get for an answer there. Okay, I'm going to erase this so we can work that one out in just a bit. Yeah, my mic is off. All right. So I just found my point, and my point is 0, 0. And you have the same point because you have y minus 0 and x minus 0. So you have the same point. So now the next thing I'm going to do is I'm going to find the derivative so I can find the slope. So the derivative of sine of x is cosine of x plus, and then this I'm going to write this way. I always do. Okay, so I bring the 2 down. So the derivative of that is going to be 2 sine of x times cosine of x. Okay, and that would be my derivative. Well, I got to put it up here. So I have. All right, so if I put 0 in here, cosine of x, cosine of 0 is 1 plus, well, this is going to end up being 0. So my slope is going to be 1. So my equation, y minus 0 is equal to 1 x minus 0. So we could just have y is equal to x, right? For our equation. I have to go back into my answer key because I think I might have done it wrong because I think I had y is equal to 1, which is not correct. And I don't want to start marking kids' answers wrong. So let me see here. So answer key 9A. Oh, that's 9B. Yep, I did it wrong. I did it right. I had the right thing, but I reduced it down to y is equal to 1 when it should be 1x. All right. That is finding an equation of tangent lines. Now, these two problems are on your assessment this week, so hopefully you get them both right. How about this one? If y is equal to x to the third plus 1 to the second power, then dy dx is equal to. Now, this is a problem off a former AP test. So what would you get there? And you can just tell, you don't have to type it in, you can just tell me which letter, which multiple choice. That would be a lot easier for you than having to type the answer in. Letter E. Okay, so if I was going to do this problem, I'm going to just bring the 2 down, leave the middle alone to the first power, times the derivative of the middle. Well, that's going to be 3x squared. I'm going to multiply the 2 and the 3x squared, so that gives me 6x squared times x to the third plus 1. So letter E is absolutely correct. And I think we only have one slide left today. All right. So let f and g be differentiable functions such that f of 1 equals 2, f prime of 1 equals 3, f prime of 2 is equal to negative 4, g of 1 equals 2, g of prime of 1 equals negative 3, and g prime of 2 equals 5. This was a AP question. I thought it was a good one. And it says if h of x equals f g of x, then h prime of 1 is equal to what? It's a pretty good problem. Okay. Letter D. I haven't done the problem yet, so let's take a look here. This is basically the definition of the chain rule, isn't it? So how do we take chain rule? We take f prime, leave the middle alone, times g prime of x. They want to know what it's equal to when x is 1. So I'm just going to put 1 in here. So I've got f prime of g of 1 times, that's inside parentheses, g prime of 1. Okay, so g of 1 is equal to 2. Okay, so I'm going to put 2 here. Then I need to know what f prime of 2 is equal to, because so f prime of 2 is equal to negative 4. So I've got negative 4 times g prime of 1, and g prime of 1 is -3. So my answer is, wow, that was amazing. Really good problem there. You really had to know a lot about functions. All right, that was it for today. Any questions? All right, have a great short week of school this week. Enjoy your 4-day weekend, Thursday, Friday, Saturday, and Sunday. Woot woot, gotta love it. Bye.